and R3 are still in series with one another, and R4 and R5 are still in series with one another. But that pair and that pair are in parallel with R2 and R3. Okay, R4, R5 is in parallel with R2, R3. Okay, now remember, like I said, what we've got to do is we've got to simplify this circuit. That's probably our first thing that we have to do. Okay, so what I'm going to do is I'm going to show you how to go through and simplify it first. Okay, what we're going to do, remember, when we're simplifying a circuit, we want to start from the farthest right side. We've got our positive side here, we've got our negative side here. So I'm going to start from this side and start working our way back, okay, in these circuits. What we want to do is we want to start off by combining R2 and R3 and then combining R4 and R5, okay, or vice versa actually. Combine R4, R5 and then combine R2, R3. So what we would come out with is our first redraw of the circuit. Is going to be like this, okay? This resistor right here is a combination of R4 plus R5, and this resistor right here is a combination of R2 plus R3, okay? We still have R1 here, so all I've done is I've added R4 and R5 together, and then I've added R2 and R3 together, okay? This is, again, simplifying. So now we've got this simplified resistance and this simplified resistance in parallel with one another. Okay, so to do that, all we do is just, remember, in series, we're just adding resistances. So what we're going to do is for this resistance down here, it's just going to be R4 plus R5. So that total resistance is going to equal 1.5 kilo ohms. R2 plus R3, okay, that is just going to equal 7.5 kilo ohms. Okay, so now we've got a 1.5 kilo ohm resistor in parallel with a 7.5 kilo ohm resistor. So what we're going to do now is we can calculate what that resistance, that total resistance, is going to be. And remember, here's our parallel resistance calculation. So it's going to be 1.5K in parallel with 7.5K. So that is going to look something like this. 1 over RT equals 1 over 7.5 kilo ohms plus 1 over 1.5 kilo ohms. Okay, so on my calculator here, I'm going to say 7.5 kilo ohms, 1 over X. Sorry, it should be a plus here. Duh. Plus 1.5 kilo ohms, 1 over X, and then I'm going to hit the equal sign. Okay, that initially is going to give me 0.0008. Okay, and we know that that's not the total resistance here. That is 1 over RT equals 0.0008. Okay, so 1 over RT equals 0.0008. Well, that's not our resistance value. Remember, we've got to invert RT, so then that means we have to invert this. So RT, I'm going to take that 0.0008 and I'm just going to 1 over X. So that's going to give me 1.25 kilo ohms. Okay? So that is for this resistance value right here. Okay? So let me go ahead and redraw this. So now we've got simply two resistors, okay? We've simplified it to two resistors. This resistor value, remember, is 1.25 kiloohms, okay? That is this combination of this parallel and series portion of this circuit. So we've got R1, which is 4.7 kiloohms, okay? So now in series, all we're going to do is just add that. So we're going to come up with a single resistor circuit that is 5.95 kiloohms. Okay? That is our total resistance for that circuit. Now, let's go ahead and put a voltage value with this circuit. Okay, we are going to say that we're working with 10 volts here. Okay? Okay, 10 volts. So we've got a 10 volt source, and we've got a total resistance of this circuit of 5.95, I apologize, kilo ohms. All right, so we've got a total resistance here of 5.95 kilo ohms, and we've got a 10 volt source. So if that's the case, Ohm's law, we can find current, okay? So we're going to come over here and put total current, okay? Current, for total current of this circuit, is going to be 10 volts over 5.95 kilo ohms. All right, so let's go ahead and calculate that. 10 divided by 5.95 kilo ohms is going to give me 1.68 milliamps. Okay, that's going to give me my total current for this circuit. Now, because we have a combination circuit like this, we have to simplify it to be able to find out what our total current is. Okay, now, of course, through that simplification, we also found out what our total resistance was. Should have written that down up there. So, RT was 5.95 kilo ohms. Our total current is 1.68 milliamps. Okay? Now, let's expand it back out. Okay, we've got R1 and this combination over here, which was 1.25 kilo ohms. So we've got R1, which is 4.7 kilo ohms. And this combination for this right here was 1.25 kilo ohms. Okay? We know that our total current here is 1.68 milliamps. So, in series, we've got a specific voltage that's going to be dropped there and a specific voltage that's going to be dropped there. And again, we're going to use Ohm's law here, okay? We've got a 10 volt source, 4.7 kilo ohms, 1.25 kilo ohms, and a total current of 1.68 milliamps. So what I'm going to do is find out what voltage drop is across this and this, okay? So we've got 1.68 milliamps. Ohm's law says V equals I times R. So 1.68 milliamps times 4.7 kilo ohms. Okay. Times 4.7 kilo ohms. Okay, for this resistor, resistor 1, our voltage drop is going to be 7.896 volts, so roughly 7.9 volts. So that is going to be our voltage drop here. Then we do our voltage for 2. Voltage for 2 is 1.68 milliamps times 1.25 kilo ohms. So 1.68 milliamps times 1.25 kilo ohms, that is going to equal 2.1 volts. Okay, so we looked here, 7.89, which we said was roughly 7.9 volts, and then we've got 2.1 volts here. So that adds up to our voltage source. So we know that we're doing the right thing. Now, this voltage drop right here, okay, is going to be the voltage drop for this series parallel part of the circuit right here. Okay, so we're going to have 7.9 volts dropped at R1. The remaining 2.1 volts is going to be dropped on this part of the circuit. Okay, now we're going to have to redraw again. All right. Remember, all we're doing is just expanding out our simplified circuit again. So we're going to have R1 right here. Okay, let's go ahead and write these voltages down here. V1 is going to equal we'll say roughly 7.9 volts. Okay, now in that previous simplified circuit, we know that current's going to be 1.68 and 1.68. Okay, so we know that 1.68 milliamps is going to be flowing through this part of the circuit. Now we can just kind of, like I said, treat this as a kind of whole different circuit within this circuit. Okay, so we've got R1. Remember, 10 volts. Here is our combination of R2 plus R3. And remember, that is 7.5 kilo ohms. And this R4, R5 combination is 1.5 kilo ohms. Okay, so now we just have 7.5 kilo ohms and 1.5 kilo ohms in parallel with one another. We know that the voltage drop, okay, across this area is 2.1 volts. Well, that's what we're going to have across each one of these resistors because they're in parallel with one another. So they're each going to have 2.1 volts dropped across it. So what we're able to find here is we're able to find out what the current flow is through this branch and what the current flow is through this branch, because I've got a voltage here of 2.1 volts and a voltage here of 2.1 volts. Okay? So, current for, we'll call this section R2, R3. So current for R2, R3, okay, is going to equal 2.1 volts divided by 7.5 kilo ohms. So 2.1 divided by 7.5 kilo ohms. So divide 7.5 kilo ohms. That is going to give us 280 microamps. That is for up here. So this current is going to be 280 microamps. All right? So voltage for 2, 3, 2.1 volts. Voltage for 4, 5, 2.1 volts. Okay? Current, we'll just put it in line up there. That way we'll know what we're talking about. Current for that is going to be 280 microamps for this right here. Okay, that's for this leg right there. That's 280 microamps. So let's find the current for down here. This is R4, R5. Okay, that is going to be 2.1 volts over 1.5 kilo ohms. Okay, 2.1 divided by 1.5 kilo ohms is going to give me 1.4 milliamps. Okay, so current for this branch, 1.4 milliamps. Now, so we simplified it. Now we're expanding it. Okay, we know that in this part of the circuit here, we've got 2.1 volts, 7.5 kilo ohms, and 280 microamps running through there. So for this branch, we've got 2.1 volts, 1.5 kilo ohms, and 1.4 milliamps running through there. Okay? So now what we're going to do is expand that out a little bit more. Okay, we're going to do that final expansion. Back to our original circuit here. Okay, so we're just going to expand it back out. To this part of this, to this original circuit. Okay, I'm going to erase this so that I can have some room to calculate down here. Okay, so we've got R1. We know that that is 4.7 kilo ohms. We know that that has a voltage drop of 7.9 volts, and it has a current flowing through it of 1.68 milliamps. Okay, now we've got these branched off, or expanded here in these branches. So we found out that through this leg, or this branch right here, the R2, R3, that the current through that was 280 microamps. These are in series with one another. So both of these resistors are going to have 280 microamps flowing through them. Okay? So 280 microamps. We know through this branch, we've got 1.4 milliamps. So both of those resistors, since they're in series, they're both going to see 1.4 milliamps. Okay? So now what we have left to do is we take these original resistances here and we can find out what our voltage drop across that is. Remember, with these being in series right here, we're going to have a different voltage drop across each one of those. With these being in series, we're going to have a different voltage dropping across each one of those. Now, when we were on a more simplified part of the circuit, we found out that through that branch, okay, and through this branch, we've got 2.1 volts dropping across those total branches there. Okay? So, realize when you're doing these calculations that if the combination of these two voltage drops is over 2.1 volts, you've done something wrong, because all we can have across this branch is a maximum of 2.1 volts. So that's what it should be. These two voltage drops that we calculate here in a second should come up to right about 2.1 volts. Same down here. This combination of these two voltage drops should come up to 2.1 volts. So, if we do these calculations, okay, voltage for 2, that's 280 microamps, and we have a resistance of 5.1 kiloohms. So, 280 micro times 5.1 kiloohms. That's going to give us the voltage drop across R2. So, 280 micro times 5.1 kiloohms. That's going to give us 1.43 volts. Okay, let's go for voltage drop across resistor 3. Got 280 microamps, okay, times 2.4 kiloohms. Okay, so 280 microamps times 2.4 kiloohms is going to give me 672 millivolts. So if I add 672 millivolts to 1.3 volts, I'm going to get 2.1 volts. Okay, so these two together are going to add up to roughly 2.1 volts. All right, and that's what we've got in that branch of the circuit. Now, let's move on. Voltage for 4. We've got a current of 1.4 milliamps times 1.2 kiloohms. Let's see what that current is, what that voltage drop is. So, 1.4 times 1.2 kiloohms. This is going to be 1.68 volts. Okay? So, voltage across 5. 1.4 milliamps times 300 ohms. It's going to be 4 420 millivolts. So if I add 420 millivolts to that, 1.68 volts, that is going to give me 2.1 volts. Okay? So we saw for everything in this circuit. Okay? We've simplified it and then expanded it back out. These are the steps that you guys have to take when you're doing this. Okay? You have to follow these steps. Now, I will redraw this circuit in more of a form that we have seen in class. Okay? Here's my supply. What we can do is we can put R1 right here. Okay? Now, we've got okay, 10 volts, R1, R2, R3, R4, and R5. This is a different drawing of the exact same circuit. Okay? So, hopefully this will help some of you guys out. Again, if you have questions, make sure you're asking me these questions through Moodle, okay? Or the Google Classroom that I set up. Just make sure that you're asking the questions, okay? Thank you.